There are a couple of special products that we need to know about that will speed up our multiplication process. First, a sum times a difference. Notice what happens to the OI part of falling if we multiply the sum of two things with the difference of the same two things. That means two things that are added together and the exact same two things that are subtracted. When we fall this, x times x, the first ones, makes x squared. The outside, x times negative 2, is minus 2x. The inside, 2 times x, is positive 2x. And then the last, 2 times negative 2, makes negative 4. But now in the middle, the OI part of the falling, notice that those are additive inverses. They are opposites of each other, so they add out. We end up with just x squared minus 4 as our answer. This happens every time that we multiply sometimes a difference. Order doesn't matter with multiplication, it's commutative. So even if the difference is in front, as long as you've got the sum of two things and the difference of the same two things, when you multiply it, the middle parts will be additive inverses. Here, x times x, the first ones, makes x squared. The outside, 3 times x, made 3x. The inside, minus 3 times x, is minus 3x. And then the last, minus 3 times positive 3, made negative 9. So now again, we've got additive inverses that came from the outside and inside stuff, and they're going to go away. So if I have a sum times a difference, the result is going to be what is called a difference of two squares. And since the middle part goes away every time, there's no need to do that OI part of the falling. Instead, we can just FLA, first and last. If we have the sum of two things and the difference of the same two things, it doesn't matter even if they have coefficients. All we have to do is the first two things together, 5x times 5x made 25x squared, and the last things together, 2y times minus 2y is minus 4y squared. The result, a difference of squares, has squares on both the front and the back with a minus sign between them. It's a minus sign because a positive times a negative gives us this negative result. If you've got a sum times a difference, just multiply the first things and the last things. But it has to be exactly the same things that you're multiplying, with the only difference being the sign between them, a sum times a difference. Our second special product is a binomial squared. If we had x plus 3 that we were trying to square, we could write down x plus 3 times x plus 3, since that's what it means, and fall it. If we do that, x times x, the first ones, make x squared. The outside gave me 3x, and so do the inside things give me 3x. Then the last, 3 times 3, made 9. But notice that these were exactly the same as each other. So I've got 2 of the 3x's. 3x and 3x together made 6x. That's true no matter what's happening with our binomials. X minus 4, if we square it, is the same as x minus 4 times x minus 4. And we can do first ones. X times x makes x squared. We can do outside to get minus 4x, but so is the inside going to be minus 4x. So together they make a minus 8x. And then the last, negative 4 times negative 4, makes the positive 16 on the back. Now, if this is going to happen every single time that we're squaring a binomial, that the outside and the inside will give us the same thing, then there's a faster way that we can do this. To square a binomial, let's square the first term. Then to get the middle, let's multiply the terms together, then times 2. Multiplying them together, x times 3 makes 3x, and then times 2 accounts for the fact that we have it outside and inside. Here, x times negative 4 makes minus 4x, then times 2 accounts for the fact that we have it inside and outside. And then we'll square the last term to get the back. So the way that'll look, take the first one and square it. That makes x squared. Multiply these together, that's 5x. Then times 2 makes 10x. And square the last one to get 25. Our answer is called a perfect square trinomial. Remember that trinomials have three terms. To be a perfect square trinomial, we have to have a square on both the front and the back. There should be a positive at the back because when you square this last number, no matter what it is, you end up with a positive result. And the even coefficient in the middle has to happen every time also, because when we multiply something by 2, it's definitely going to end up being even. So perfect square trinomials come from a binomial being squared. We square the first term, we multiply the things together, then times 2, we square the back one. Let's try one more. First one, if we square it, makes x squared. Multiplying the things together is minus 6x, then times 2 makes minus 12x. Square the last one to get plus 36. A perfect square trinomial with three terms, a square on the back, a square on the front, even in the middle, and positive at the back. The sign of the middle matches the sign of the binomial. The sign of the middle matches the sign of the binomial. So to square a binomial, square the first term, multiply the terms together, then times 2, and then square the last term. Your answer will be a perfect square trinomial with squares on each end, positive at the back, and even in the middle. If you have a sum times a difference, the result is a difference of two squares. You can get your answer by multiplying the first ones together and the last ones together.